This is in Khao Lak, Indonesia, where a tsunami struck in 2004. The tsunami came through and actually washed away the shoreline so that it ended up looking like this. This is imagery that was collected immediately after the tsunami. There's a lot of land devastation, washed out areas, destroyed homes, and cut road networks. The Disaster Relief Center has therefore been tasked with mission planning for humanitarian relief efforts. The main focus is to get food, water, and temporary shelter in place as soon as possible. The first thing to do is to compare the differences from before and after the tsunami, which is called change detection. What changes occurred? How much devastation has actually taken place? RemoteVew is one of the best tools available for this. All we need to do is grab the first image and drag it over to create a comparison between the two. This will automatically geographically align the two images. We can grab the middle, and we can actually swipe this left and right to see after and before. We can easily see the amount of devastation that has taken place. Another useful tool for change detection is referred to as colorized difference. This method colorizes the two images with red, blue, and gray. In this case, the red is from the older image but does not exist in the newer image, and the blue is from the newer image but does not exist in the older image. So if one were to interpret this automated analysis, they would know that the red area is coastline that no longer exists, whereas the blue area is what used to be green and lush and has now been destroyed. These grayer tones are areas where there hasn't been an exceeding amount of change. This gives us a baseline from which to proceed for developing a disaster relief information package for humanitarian assistance mission planners. We can use other tools within RemoteVew to see how much devastation has taken place. For example, with the line tool, you can draw a line over the red area and determine how much of the coastline has been washed away. So in this case, we can see that 147 meters of the shore is no longer there. Now we're going to launch 3D Pro. In the time that it takes for 3D Pro to start, it combines the 2D image with the underlying elevation data and the newly generated 3D models to create an entire 3D scene. Now we can check out some different viewpoints that were previously set. In the distance, you can see the car, while up here we have set up a UAV model to follow a flight path. This model is showing a field of view that is meant to project what the UAV would be seeing as it follows along its set path. This enables mission planners to have an initial idea of what areas to focus on for persistent coverage after such a disaster. This is the area that we want to focus on in terms of survivors and supplying relief. You can see where the shoreline has been washed away, as well as this set of buildings where we have some survivors waiting to receive help and aid. The primary thrust of this mission will be to reach these people with humanitarian aid packages. As we analyzed the imagery, we realized that some of the road networks had been cut off by the tsunami. Because of the damaged roads, we need to set up a primary and alternate landing zone for relief helicopters. So here's one landing zone that we have set up on this side of the washed-out area, and here's another landing zone on the opposite side. In fact, if the current landing zone is selected and moved around, you can see how it actively adjusts to the terrain and the 3D models of the trees in accordance with the parameters that we have set. If the elevation becomes too extreme or the trees interfere with the landing zone, the ring becomes red or unsafe. Next, we'll examine one of the fly-throughs. First, we'll make it a loop, and then we'll select that we want to see the fly-through from the UAV's perspective. So here's the UAV flying around. Again, this gives an idea of what type of video or imagery one can expect to get back from the specified flight path. Here's the other vehicle that we set up to drive along the road. The red is showing what the driver can see, whereas the blank area in the same field of view denotes what the driver can't see as he travels along that road. We can continue to move around the scene from the UAV's perspective, or we can even allow it to follow along the flight path on its own, while we are free to move around the scene as we see fit. RemoteVew and 3D Pro possess excellent tools for humanitarian relief. From precise measurements and change detection to detailed analysis and quick 3D projections, we have the ability to know exactly what has transpired after a particular disaster and how to brief the crews that are prepping to deliver much-needed humanitarian aid packages.